In this explainer, we are rolling up our sleeves and diving deep into the hydraulic brake system to master a tiny but literally absolutely crucial piece of engineering, the residual pressure valve, or RPV. You know, it's a component that gets overlooked way too often, but mastering it, that's exactly what separates a basic parts changer from a true lead mechanic. Let's get to work. Okay, let's just quickly breathe through our diagnostic playbook for today. We're going to meet the pressure valve, look at symptoms and failures, run through the actual diagnostic procedure, uncover those tricky conversions and hidden valves, and finally lock down our installation and safety rules. Section 1, meet the pressure valve, the rules of residual pressure. Because hey, before we can properly diagnose a broken system, we've got to totally understand a perfectly working one, right? So what does this valve actually do? Well, when you let your foot off the brake pedal, the return springs inside a drum brake pull the shoes back, which pushes the wheel cylinder pistons inward. Now, if there's literally zero hydraulic pressure holding them back, those pistons retract way too far. It creates this tiny gap between the piston cup seals and the cylinder bore, and bam, suddenly your brake system is sucking in air. The RPV is a brilliantly simple solution to this. It's a passive, one-way check valve that traps just enough pressure, usually around 6 to 18 psi, to keep those seals expanded tight without actually applying the brakes. Now check out the contrast here between our two standard ratings. On the right, we've got the 10 psi valve. That is the gold standard for drum brakes to keep those seals perfectly expanded. But on the left, we've got a 2 psi valve. This little guy is used only for disc brakes, specifically when your master cylinder is mounted lower than the calipers, just to prevent gravity drain back. As an apprentice, hear me on this. Never, ever mix these up. If you throw a 10 psi valve on a disc brake system, you are going to cause immediate brake drag, totally overheat the rotors, and absolutely shred through your brake pads. Moving on to Section 2, Symptoms and Failures, Anatomy of a Breakdown. We know how it's supposed to work, so what happens when these things go sideways in the field? Inside that compact little housing, you've got a check ball or poppet, a precision ground valve seat, and a calibrated coil spring. And let me tell you, cracking open a failed unit often tells a pretty tragic story. You might find the valve seat is completely scored up from dirt and debris. Or maybe you'll see internal spring fatigue, where the spring has just lost its precise preload. There could be carbon fouling choking things up, or even worse, total seal degradation from incompatible brake fluid. Contamination is literally your #1 enemy here. It just destroys the mechanics from the inside out. So picture this. You've bled the brakes. You've bled them again. But why is the brake pedal still spongy? This right here is constantly misdiagnosed by weekend warriors who think the system just needs another bleed, when in reality, they're fighting a fundamentally compromised valve. A valve usually fails in one of two ways. If it's failed open, it's just not holding that 10 psi anymore. Your seals collapse, air gets sucked in, and you get that terribly spongy pedal that you have to furiously pump just to get any firmness. But contrast that with failed closed. If that tiny internal check ball gets jammed shut, it completely blocks forward fluid flow. Your pedal might feel rock hard, but guess what? The wheels aren't going to stop. That is an immediate catastrophic safety hazard. No joke. All right, Section 3, the diagnostic procedure, the mechanic's playbook. Grab your tools, everyone. We aren't guessing here. We're going to prove what's wrong. Let's walk through the actual step-by-step diagnostic tests. The absolute best way to prove if a valve is doing its job is the pressure retention test. You're going to hook up a hydraulic pressure gauge right at the wheel cylinder or line. You fully mash that brake pedal to generate high pressure, and then let it go. Now, keep your eyes on the gauge. A healthy 10 psi valve will show the pressure dropping, sure, but it should catch and hold steady right between 6 and 12 psi. If that needle plummets straight to 0, your valve has failed open. Let's take it a step further with the isolation test. Say your pressure did drop to 0. Well, is the valve bad, or is the wheel cylinder leaking? To figure this out, carefully clamp the brake line near the wheel cylinder using a proper non-damaging brake hose clamp. Release the pedal again. If the pressure now holds steady at the gauge, your RPV is the confirmed culprit. But if the pressure still drops with the line clamped off, you just proved the wheel cylinder itself is leaking. Boom, diagnosed. Section 4, Conversions and Hidden Valves, Wrenchwork Traps. This is where we talk about the hidden traps that absolutely ruin so many DIY drum-to-disc conversion projects. A huge danger on older rigs is the hidden valve. A ton of factory master cylinders from the 1950s all the way through the 80s actually have a 10 psi residual pressure valve integrated directly into the outlet port. It's completely invisible from the outside. You literally wouldn't even know it's there unless you specifically knew to go hunting for it. And that brings us to the golden rules for drum-to-disc conversions. If you're upgrading an old drum system to a modern front disc setup, you absolutely must locate and remove or bypass that factory 10 psi RPV. Standard disc circuits need exactly 0 psi to function right. Their square-cut piston seals act as their own return mechanism. If you leave a 10 psi valve hidden in that circuit, I guarantee you'll get constant brake drag, boiling fluid, warped rotors, and totally destroyed pads. Section 5, Installation and Safety, Shop Floor Rules. Okay, we've diagnosed the problem and we're ready to put it all back together. Let's look at the strict protocols for doing this safely. When you are installing a new valve, precision is everything. You'll run into common thread standards like the standard North American 3/8 24 UNF or the metric M10 by 1.0. You obviously have to match the threads perfectly, but hitting the right torque is just as critical. Inline fittings generally require 9 to 12 foot-pounds of torque, while a master cylinder port needs a bit more, usually 15 to 20. Sticking to these exact specs is literally the only way to prevent those tiny microscopic fluid leaks and air ingestion. Next up, fluid compatibility. The internal seals of an RPV are usually made of standard nitrile rubber, which is completely happy with glycol-based fluids like DOT3, 4, and 5.1. But if you pour DOT5 silicone fluid into a standard system, total disaster. The silicone immediately swells and destroys those nitrile seals, causing permanent, catastrophic failure of the valve. Always, always match the valve material to your fluid type. I want to make this crystal clear. Never use PTFE tape on brake fittings. Seriously, don't do it. When you thread the fitting in, tiny little fragments of that tape can easily shred off and get pushed directly into the brake fluid. They act like homing missiles straight for the internal poppet of your brand new valve, permanently clogging it open or shut. Only use approved liquid hydraulic thread sealants. Now, before a vehicle is ever allowed to roll out of this shop, it has to pass our critical safety sign-off. First, double-check that the directional flow arrows on the valve point toward the brakes. Install it backwards, and you've got no brakes at all. Apply your liquid thread sealant, torque it to spec, and bleed the entire circuit completely. Then, with the engine off, do a 30-second pedal feel test. Hold that pedal down firmly for 30 seconds. If it sinks even a fraction, you have a leak. Finally, tell the driver to bring it back for a quick visual inspection after 50 miles. I'll leave you with this golden rule from the shop floor. Always match the RPV pressure rating to the brake type and always install with correct flow direction. It's inexpensive insurance against complete brake failure. Now that you understand exactly how these tiny, unassuming valves control the actual safety of a vehicle, I have to ask you, do the brakes you've been working on lately actually have the correct residual pressure setup? Think about that next time you pick up a wrench.